Hi everyone, so my name's GIlmore. I'm an AWS Serverless CRO and Principal Cloud Architect from the Northeast. And today what I want to talk about is the key questions teams currently have that I've worked with when it comes to event-driven architectures and microservices. So starting in serverless is really simple. You can get something spun up really quickly, but what you typically find is organizations grow, so do the number of teams, the integrations with third parties, on-prem, and this now brings up these new complexities and questions. So usually this is a 45-minute talk with 10 questions. I'm going to squeeze it into 5 questions, 25 minutes. But these are the key questions that I typically get, having worked with some of these companies at the bottom here. And what I'd like you to do is to go away from here knowing some of these concepts, high-level concepts, but to deep dive in your own time. So just so we're all on the same page, what is EDA and microservices? So if you're like me, working 20 years ago, for example, on .NET Framework applications, it was really simple to get going. And what you typically find is as the organization grows, it becomes more successful. We add more engineers. We've got, it typically goes from being really easy to deploy and work on these applications to being quite complex, people standing on each other's toes. We find we sometimes have low cohesion. So we find things like identity management lives with order fulfillment, that lives with pricing. So everything's quite tightly coupled and very low cohesion. And sometimes this is called a big ball of mud architecture. Now, the natural conclusion was to pull this apart into microservices. And this is where we are today. So this is like the early 2000s. So we now have smaller services that are deployed separately. They have their own databases. And we get this rapid innovation at this point. But with these services, a lot of them are talking synchronously between each other. Again, not great. So we've got that tight coupling. Now, there wasn't a cut over from microservices to event-driven architecture. EDA has been around since the 1980s. Many of us would have heard of SOA-style architectures with an enterprise service bus. But where we are is we're trying to decouple these different microservices where we are event-driven first, so we're async. And where we are today is we've got many of these different services we can plug together really quickly. So here we've got Amazon Event Bridge, we've got API Gateway, step functions, SNS, SQRS. We've got a full plethora of different services we can plug together. And this gives us this speed and agility, definitely with direct integrations as well. And we have these new evolutionary architectures where we can quickly listen to an event and now build another process or another microservice on the back of it. But with this comes a lot more questions. Because again, it's really easy to build a big ball of mud with all of these small services plugged together. So one of the first questions I typically get is how do we define the right boundaries when we're doing this? So this is a great quote from Robert C. Martin, who wrote 2 books on clean code and clean architecture. So good architecture is one where the boundaries between subsystems are clear and well-defined. So this isn't a talk on DDD, but we're going to cover some high-level concepts that are going to help us understand these boundaries. So a domain is your overall organization. It is all of your people, processes, technologies, systems that are all working together to form that wider organization. So a subdomain is a logical part of that, where you've got distinct business capabilities. That's your subdomains. And we can work with the business really closely, as you can see here, so technical teams and business stakeholders, to try and understand what these subdomains are. And a lot of the time, you can do business capability mapping. Sometimes it's just a gut feel with getting in a room and discussing what these might be. And what we do then is we try to work out the 3 different types. So we've got core subdomains. Now, this is where we want to spend a lot of our development effort. This is what makes us unique and competitive against our competitors. It's our business differentiating functionality. And this is where we want to deep dive into these areas. We want to discover more and this is where we build microservices. Then we've got supporting, so these are subdomains that underpin our core domains, but don't really give us competitive advantage on their own. So you might want to outsource these. So we've got things like data and BI. It could be integrations and messaging, for example, or we might just want to buy off the shelf. And then we've got generic. These are things like identity management. We're all using the same services, so there's no point in building that from scratch. We're just going to use SaaS products. So what we can do now is we can deep dive into some of these core subdomains so we can understand them better. And there's a lot of different ways we can do this. One of them is event storming. And again, we work really closely with the business and the technical teams. We get in a room with lots of different color post-it notes, and we start to map out through temporal sequencing, so time, left to right, what the different events are that are happening. So it could be order created, payment processed, for example. Then we start to add the commands that are essentially creating these events. We start to add the actors that are involved in the process. Views, for example, so we've got those kind of green post-it notes there. And we build this up so we understand the domain model of that area. So all the language, the commands, all of the rules. And then what we can do, we can start to understand the bounded context. Now, these aren't discovered. We're actually going to design these. But we look at some key areas like language. Where is that language distinct? We look at transactional boundaries around data. So, for example, here you can see we've got an order, which is in order fulfillment and basket and checkout, but they might just have the same name. There might be completely different things to different people. That language is distinct. So we can start to build out where these bounded contexts are between our systems. And ideally, it's a one-to-one mapping between a subdomain and a bounded context, but naturally it doesn't have to be. You might find that you've got multiple bounded contexts within a subdomain that's fairly complex. And this is very opinionated, the way I work, but once we've defined what these bounded contexts are, and they're going to communicate with each other through events and synchronous calls, I typically go with a microservice equates to a bounded context. And this way we've got our encapsulation around the data and the language. We've got contracts for things like OpenAPI for our API definitions there. We're publishing public events, so other bounded contexts on the right here can consume them. And we're also going to consume those as well. So we've got these contracts around our APIs and events. So the next thing I usually get is, well, how do we actually access the data when it's in a different subdomain? Because we've talked about encapsulation. So if we look at this example here, we've got a customer management system on the left, and we've got order management on the right. And in the customer management system, we want to show the customer record with all of the recent orders, but the data is in completely different bounded contexts. So one way we can do this, we could do a call across synchronously and grab that data, but obviously that's quite coupled. And if the order management domain went down for whatever reason, what are you going to show on the customer side? There isn't any orders to actually show. Now, this is where we can use something called read stores. And we can see here the order management domain is publishing events anytime there's a state change. And this is a FAT event, or event carried state transfer. So we can see we've got order items, we've got descriptions, we've got prices. And what this means is the customer management domain can consume that event across this event bus, and it can create a read-only cache or copy of that data. So now it doesn't need to reach back out to the order management domain. It has a local copy. It's more decoupled. But we're more coupled now on the contract because, as you'd imagine, this has a schema, this event, and that is likely to change because there's a lot of properties on there. So one way we can do it is the event notification pattern, and this is where we use slim events. So the same thing happens. There's a state change in the order management domain, something like order created. But now you'll see that event just has the order ID and the customer ID. So that is unlikely to change over time. So now the customer management domain consumes that event, but it doesn't have all of the data to write directly to that read store. So what it does is it calls back out across via the API and gets the data it needs. So we're less coupled now on the contract, but more coupled on the call across. And it's all trade-offs, like any architecture. So you've got to do what's right for your business. So read stores are great for decoupling these systems. We've got less synchronous calls between them. Event-carried state transfer means we are less coupled on an API call going back across, but more coupled on the schema of the event. And the notification pattern is the opposite. We're less coupled on the schema, but we have to have that API call across to get the data to put in the read store. And one thing I've always said to the teams I work with is this is eventually consistent, this data. So don't use it for mission-critical business logic, but it's great for very basic business logic or for view stores. So we've seen we can build read stores based on events, but how do we make sure that we always publish an event? That's one of the key things. So if we look at this problem statement, we're sticking with the same subdomains here. So a new order is created on the right-hand side, and we write it to the database, everything's fine, but we go to publish that event, and for whatever reason, there's a bug or there's an issue with IAM, for example, some kind of permissions. The customer management domain doesn't consume that event. It doesn't happen. So now it obviously has stale and inconsistent data on the left-hand side. Or it could be the opposite. What if we go to write in a transaction to the database, we then publish the event, so it goes across and the customer management domain consumes it. They write it to their read store, but that transaction on the right-hand side rolls back for whatever reason. There's been some kind of issue. So now again, we're in that inconsistent state where we're showing an order that hasn't actually happened. So one way we can get around this, and again, this isn't a new pattern, it's been around probably as long as DDD, is the transactional outbox pattern. And what we're going to do is anytime we actually write that new order or that some kind of state change, it could be the creation of an order, it could be order amended, for example, we write the state change to an outbox table at the same time. And we do this in a transaction. So we've got the order item and we've got the state change. And this allows us to then have this consumer that's going to poll continuously. It's going to grab that state change from the outbox. So think of it as in an outbox where you grab it from the tray. And we then publish that across. So we make sure that we always have the database record committed. And obviously we now have the publishing of the event. But many databases now have something called CDC, or change data capture, where we don't explicitly have to write to an outbox at the same time. So if you think of DocumentDB, which has change streams, or DynamoDB, which has DynamoDB streams, we will get a stream of changes, whether it's a creation, a modification, or a deletion on a stream, anytime something happens to this order database. And we can then consume that, put it on a queue for resilience and high availability, and we can then publish that across to the left-hand side or any other subdomains that are listening to that event. So how might we do this on AWS? So we can see here at the very top, we've got an orders API gateway, a Lambda function for creating the order. We're writing that to the orders table. There's that state change, and we've got DynamoDB streams. And we could have a Lambda function, put it on a queue, and then we could publish that event for all others to consume. Or we might decide that we want to use event bridge pipes because we want to enrich the data, or we transpose it, or change it in some kind of way before publishing. And there's many other different architectures we could do with different services that have CDC. So a couple of things to consider. So these two patterns allow us to observe these changes and publish the events consistently. So we're always going to publish them. And if we use AWS managed services and plug them together directly, we don't have this glue code. We don't have to write Lambda functions that might have bugs in them. And this allows us to have consistency across data boundaries, but it is event-driven, so obviously it's eventually consistent. That's one thing to consider. And these patterns are typically also used with event sourcing and CQRS. So what the heck is event sourcing and CQRS? That's the next question I usually get. And many of us would have heard these terms, but not actually done it in production maybe, or these are typically questions in interviews in my experience that people ask. So let's delve into it a little bit. So top left, we can see here that on most CRUD systems, we write a single record and then we manipulate it, we update it over its lifetime. So if we want to query that record, we'll get it by ID, for example, and just grab that record. But we lose any audit history unless we look at something like CloudWatch logs, which isn't great for having that immutable list of what's actually happened. So what we can do instead, we can write commands anytime there's a state change. So we can see here we've got create order, we've then got multiple updates. So we've got these commands being written to the database. So we've now got this immutable append-only log, which is great. We can see everything that's happened. So think of a banking ledger or your balance on your bank account. We have all of these credits and debits that ultimately equate to your balance. But it's not very good for actually getting the current view, because what you have to do is replay all of these commands in order just to get the current view. So one way of doing this, we can add snapshots. So imagine if you've got 1,000 commands that's happened to a given entity. So going back to the order example, we don't want to replay 1,000 records just to get the current view every time we want to get it. So we can use something called snapshots. And this could be written every 1 record, every 5, every 10. Again, it depends on your business. But we can write the current snapshot and then just replay the events that happen after it, the commands. So you might be able to throw away and forget about the 955 records, what have you, and just get the last 5. But it's still not great for querying. And this is where CQRS comes in. So these are 2 separate patterns, event sourcing and CQRS, but they're typically used together. And this allows us to split the reads and the writes, and we use the best database technology for both. So we can see on the left, all of the commands are using event sourcing, and we're writing to a database. We've got CDC, as we talked about earlier, so we're streaming the changes now and writing those that materialize view to another database. And this could be the best database based on SQL, for example, if that's your needs. It could be document-based, whatever it is that allows you to quickly search and get the most out of that database. Now, what might this look like on AWS? So we can see here we've got this API. We're pushing all of our mutations, so the creates and the updates to DynamoDB. We've got a stream there, which is going to EventBridge pipes. And eventually it's getting to this SNS FIFO topic. And the reason we're doing this is we've got 2 separate processes. We want to publish, top right, the event to other domains. And that allows them across bounded context to consume that. But internally, we want to index to open search those changes. And this allows us then to have the writes going to the DynamoDB table, and all of the searches are now going to open search. So we can have fuzzy matching, we can do pagination, sorting, and querying very easily. So things to consider. So event sourcing is a great pattern to have that history of changes, and it's great for compliance. One thing to be careful of, obviously, is as you're writing the commands, if the schemas change at all, it might be quite difficult to then replay all of those events. You could bring in a bug of some description. And CQRS doesn't mean one materialized view. You could create many. You could have SQL-based for one reason, OpenSearch for another, and DocDB for another, for example. So document-based. But CQRS is complex. So the final thing is, how do you use EDA when you've got third parties and on-premise solutions? Because most of us are not just working with AWS and cloud. So a lot of the time what you find is they have different semantics or different ways of working. So you might find that a third-party application can't write directly to EventBridge, for example. It can't publish an event, or it can't write a message to an SNS topic. And what you might find is they've got legacy protocols, or the payloads have very poor naming conventions, for example. So we don't want to consume this and publish this event for other subdomains to listen to. And this is where we can use the event gateway pattern. And this is essentially where we put an API in front of our messaging service or eventing service. So we've got EventBridge here, which has an API in front of it in this example. And this is because most third parties or on-premise solutions can work with REST or webhooks. So this allows them, when there's a state change, to hit our API. We can take that event, put it on the event technology we're using, and then other domains cross-account can consume them. So again, what might this look like on AWS? So we've got this third party that's publishing some kind of webhook to API gateway. We've got a Lambda authorizer doing the authentication and the authorization there. And then we've got this Lambda function that's going to validate the payload against a given schema. So that might be based on the domain or subdomain, the service, and the event type, for example. And the key thing we want to do here is use it almost as an anti-corruption layer. So we don't want to publish that legacy protocol or poor payload across to lots of other subdomains. So we'll transpose it into the correct shape, put that onto the event technology. So for us here, it is Amazon SNS FIFO. And then cross-account, we can have these SQS subscribers subscribe to these different changes. But what if it's the other way around? What happens if they want to publish events but also consume them? Again, they might not have the same semantics. So what we can do in this regard, we can create a microservice that lives in the correct subdomain. So we've got sales and billing in this example. And it's going to consume that message or that event. And it's going to work almost as an anti-corruption layer the other way. It's going to transpose it for the correct shape for that third party or on-prem. Now, that could be something like SFTP, it could be REST, it could be GraphQL, it could be anything essentially. But what this allows us to do is to take that event, change it into the correct shape, and then drop it onto that third party or on-premise solution. So that's given us that two-way communication. So things to consider, there's lots of different event technologies that you could use. So EventBridge, SNS, MSK, Kafka, it could be anything. The pattern is we've got the API that works as that gateway in front of that event technology on that central integration layer. And we should always validate, obviously, those payloads before we take them in and push them out to different domains. And we're going to need authorization, authentication, but also things like rate limiting. We need usage plans, API keys. And if we are going to use SNS, one of the things that hit us at a previous company is there are subscription limits on SNS. So what we did is when we took the payloads from API Gateway, we had different SNS topics depending on the subdomains, and that allowed us to fan out further. And these two approaches together are very good for strangling monoliths. Again, that's something we've done at a previous company. So you can listen to events in an on-premise solution, for example. You can start creating a read store on the left-hand side, and then over time, you can swap the primary and secondaries, and they're kind of swapped over. So thank you for listening today. I hope these high-level patterns have been useful for you, and I urge you to go and deep dive in your own time, learn a bit more. I've got some articles there at serverlessadvocate.com. I know there's other speakers today that have articles on these same topics, and also have GitHub repos you can pull down and play around with the code. And I think there's a break coming up soon, a coffee break. So if anyone's got any questions, come and grab us, and we can have a chat about some of these. Thank you.